How you doing, everybody? Randy Richard in the shop. This is part 2 to the closing lathe, a variable speed pulley repairs and overhaul. So please subscribe, please share, and thank you for everyone's support. And I still have brass scribes and round scribes available. I'm kind of pushing them here. Please email me if you still want one. There's not a lot left, and I'd really like to get rid of those. And anyway, thank you guys. Thanks you for all the great support, and thank you for just everything. All the comments are wonderful, and just thanks for everybody. And viewers are just great these days. Like I say, they're great comments, and we got a lot of good content coming out here, and that I'm working on more videos. So hope you enjoy. Please stick with me. Thank you. Horrible, Dad. So this is the pulley. We still haven't finished it, but we're getting there. But we got it welded in. So before you holler at me for what I did and all that, this is a repair. This is trying to save something. So So what I did is, you know, I dropped this in, and it shrunk in. This is cast iron. This is way dirtier than I anticipated it to have been. I mean, yes, it was covered in grime and stuff, but it's also made in the 60s, the lathe. So it was so impregnated in the cast iron. Unbelievable. So this is silicone bronze, and we tried to start welding it, and it was just so bad. So then I machined away part of the cast iron, about an 1/8 of an inch deep, about 1/4 of an inch wide, and that really helped. And then went back here and welded it, you know, machined away all the old weld and re-welded it. So it's a lot larger. But we got out here a little far maybe, and back out of right to the edge of machining, and it was pretty dirty. You could see there where it eroded away a bit. We were TIG welding this. So, you know, as far as the weld goes, now I've machined it again because we had a lot of weld there. It wasn't too bad. And now I machined it down to a nice big radius. A little low here, but that's all right. But other than that, you know, it's pretty good. There's no real inclusions in the weld. A couple low spots. A low spot there. A little erosion on the edge. But you know, for what it is, it's really not too bad. And it bonded well. It wetted and bonded well to the cast iron down where we machined it. Just out here on the edge, it doesn't look too good. So, you know, it's a repair, and I think this is gonna probably work out just fine. So that's where we're gonna leave it. So now we're gonna put it back in the lathe. This way, we're going to get this finished. Yeah, I'm not sure what I'm going to do. I might grab it this way and bore it, but the problem is I need a counterboard on this end. So I'm thinking I'm going to put it in this way. I'm going to do all the boring from this side, so it's one setup. I can bore it to final size, counter bore it, and turn the outside all to final dimensions in one setup. So that's what we'll do. Yeah, we got quite the setup here. This is a tapered bushing or pulley. So this is sloped, and I'm within 2 on the face and 1 back here and about 5 out here. So after doing all the heating and welding on it, but we have enough material to true this all up, I think. So we should be real good. A lot to remove on the bore. The bore's no problem. Out here, 50 thousandths or so. So we should have plenty to make it all real good. I got my 3/4 inch boring bar in here. This is a solid carbide one. Really nice for going this deep. We're a little over 4. We're not almost 4.5 inches. We have to go here. We'll take light cuts, but because of how we have it held and all. We got 20,000 depth of cut. A little vibration there. This might be too slow. A light vibration. Oh yeah, that made a nice chip. See, it broke up real nice. This will be the last cut here for this counter bore. All right, so I was about 2 thousandths over on my OD, which was just fine. I mean, it was too tight. We'll put it that way. It was too fine. I could not get this on, and I've polished it up, which is good. It needs to be nice and smooth, so this will slide freely. But as you can tell, I'm down to about 4/10 difference in length, fatter out here, and I could take off probably another 1/2 thousandth, maybe. It's still, I mean, it slides, but it's that just a little too much grip probably. I'll just do a little bit more. So there we go. make it so it just fits this. It's very smooth, this bushing that's in here, and the key will capture it so it doesn't spin. Or none of this spins relative to this anyway. All spins together. It only moves about an inch. It doesn't move very much. I could probably go smaller. That's probably good enough. That's pretty good. Pretty nice fit. I think we're going to leave it. Alright, we're all set up here to cut the 1/4 inch keyway, and I'm going back and forth here getting it down so we got a 1/4 inch wide flat spot to measure from, and you just inch on down till you have a flat spot as wide as the mill. I got a 4 flute carbide mill in here, and then we're gonna cut it in one shot using a little air there just to evacuate to keep the chips out so you don't overcut them. This is like I said, 1/4 inch keyway, and then down at the end of it, what we're going to do is going to cut down all the way through to the open bore where the motor shaft is. That part is a thicker section there, and end mills don't drill well, but you can peck on down. This is a center cut. You want to use a center cutting end mill for this, and that's what this is. And we're just going to peck on down all the way through, and then come back 400 thousandths for a through hole through there. So we're going to make a very special key to fit this. And now's not time to screw this thing up. We got a lot of work into this so far, and I still have to, after this is all done and making the key, then I have to drill 2 holes. I'm going to put 2 grub screws in to hold it tight on the shaft. Down, we'll do them 90 degrees to where this key slot is, and it'll be a thicker section where that is, so we can put some. Let's put 1/4 inch, 1/4 grub screws in. So far, this is project's going very well. A lot of work, but I think this is going to work out quite good. We got some real good sliding fit on there, really smooth. So no need. You don't want any lubricant because lubricant's going to get on the belt. I was thinking of putting maybe some graphite, a little bit of graphite powder on there. That would act as a pretty good lubricant in there, a nice dry lubricant. So I'm milling back here. I punched through, and I'm milling back the 400 thousandths. And pull it out. There we go. Goes down, and then it goes down and through. So it's going to be a very special key. Sits in there. There we go. 1/4 and 5/16 up here. Stepped. We're going to round those off the file. Well, we're just about there. So there's the key I just made. Now I've had to fine tune it back and forth to the mill, taking off more off of here, filing in a nice little radius around here so it didn't get caught on the edge where it goes in here, that edge in there, and I took a little bit off that edge. So that's 1/4 inch key here, and then 5/16 up here, and that goes in there real nice. It comes all the way through to where the motor shaft is down in here, and it's still sticking out a tiny bit. I still have to clean that up a little bit, but the bigger part was getting it to fit here with this. Here's the bushing in there and into the 5/16 keyway that's already in the pulley. So that took a little fiddling around, but that slides on nice. That's about far as down as it needs to go. I have a mark in there. Yeah, right about. That's as small as it really will probably go. We're going good. Pop the bearing in there. This thing's kind of loose and has some drive pins in there. I'll probably snug up. I think that must be for heat buildup, a little like a heat sink. It's made of aluminum. And I need to put a couple grub screws on this to hold it on the motor shaft. So that's where we're at. It's looking good, looking good.